Hi, my name is Carl Grayling. I'm one of the founder members of Gatfol, a language semantics technology startup with international angel seed funding and operational roots in the European Union through the UK and Malta, and in Africa through South Africa. Together with an on-off team, over a period of about 9 years, we've built a very powerful cloud-deployable inline real-time keyword equalization infrastructure. Our core language algorithms were provisionally patented in the USA in 2011 through the United States Patent Trademark Office based in New York. Our solutions currently serve in the region of just over 25 large industry application fields. Gatfol exists to make the jump from current keyword technology to a more human form of database querying. In this video, we will run a slow down and occasionally stopped operational setup that we annotated so that functioning can be seen on screen. While it is running, I will briefly cover some operational aspects of Gatfol functionality. I apologize that it makes for quite a boring visual experience, but hopefully you'll be able to see some actual semantic thinking and processing with the operational annotation whilst I'm speaking. The Gatfol production engine is a fully automated, self-feeding, self-regulating, Hadoop-style, massively scalable set of interchangeable master and slave software cloud installations. It functions in a system architecture comprising 4 functional levels with up to 10,000 master and slave agents per each instance, capable of processing in excess of 70 megabyte of text throughput per second at over 100 million semantic transformation operations per second. Although Gatfol functionality is optimized for English, any natural language can be processed. The Gatfol cloud system receives API-driven text input from client database engines and returns database relevance, ranking, order, or synonym optimized search queries. This is fully inline and in real time. Let's look at the first of the Gatfol system levels, multiple massively scalable RSS feed crawlers. Just going to drag one in, start that up. Okay, we can run anything up to tens of thousands of these instances per each cloud application. All instances direct and correlate output to a central point for processing further downstream in the Gatfol operational system. We decided on an RSS-based raw word gathering system to avoid the authorization issues in crawling random sites as pure web crawlers. And also because the ratio of linguistic noise, spam, technical jargon, text from ads, etc. to quality language input is very high with the latter. Currently, each reader links to around 1,500 feed sources across a wide field of topics. With 1,000 readers, for instance, we have 15,000 simultaneous input feed streams. The feed streams are monitored to make sure that duplicate content is avoided and that word linkage is normalized to avoid too low or too high linguistic complexity. All readers are fully automated in terms of housekeeping and health of feeds, and no human input for running is necessary at all at any stage. We've been running a set of readers continuously for the last 3 years with no operator input at all. We can see here a rough indication of output volume, and at the top here, 2 megabytes per hour. This is final processed clean text and not raw feed, which is approximately an increase to the ratio of 100 to 1. Volume here is not that important. So much downstream processing in the latter matrices takes place that anything up to 100 megabyte per hour clean text here is more than adequate to drive the full master and slave operational delivery system of tens of thousands of instances. We perform around 20 different punctuation, grammar, and quality checking algorithmic operations on the raw input to ensure that output is a good representation of current web language use. Let's see if we can grab some cleaning operations as we have a look at this. So we can see here more than X independent numbers, that's been rejected, too many numbers. More than X% words starting with a capital, that could be some lists, that's also rejected. We rule out things like normal web things, web words, plugin, user, daddy, and then obviously words that we don't really want, Viagra and those kind of things to rule out the ads. I can think of one other one, maybe too many numbers, those kind of things. There's many tests that we perform at this level. Our second report window here, if we look at this, where my cursor is, shows the raw feed text coming in before any processing, and the last window, text after processing. We do a huge amount of processing to get the text clean and to get it acceptable at the end. Just to finally summarize, the first of the 4 main Gatfol operational functional systems feed into the next level of operation and ensures that just the very current web language is taken into operation to eventually be used in output production. Within roughly 10 seconds of a major happening anywhere in the world, let's say generating a unique set of word combinations, The new word concept combinations are amalgamated and processed into the Gatfol system to be immediately functional client processing. The RSS feeders run integrated 24/7, and as said, we have been running an uninterrupted feeder population, fully error-free and human hands-free over the last 3 years of development. Our next functional level, let's just close that down. Our next functional level, system level, is a massively scalable processing operation. This is the building of two-dimensional synonym word relationship matrices. This system level feeds automatically from the first feeder level. It can also be scaled to fully integrated tens of thousands of instances, and again feeds fully automatically into the next level of operational functioning. This functionality took several years to build, as the synonym relationship matrices are again human hands-free in terms of growth, error correction and housekeeping operations. This level of functionality runs 24/7 from raw grammar feed from Gatfol Systems Level 1. No dictionaries or other process feeds are used. We found this an incredibly difficult technology to master when we started looking at accuracy acceptance levels of above 85%. We studied many years into many newer semantic multi-word synonym technologies and found that although mathematical complexity can be very high, almost all final acceptance levels struggle to break 80%. We eventually opted for a hierarchical build model of a fairly simple algorithmic processing, where each level in the model just solves quite small, simple equalization problems. Our view is that language is such a disparate collection of word repetition habits and patterns that a one-shot algorithmic approach, no matter how advanced and complex, fails to address all the analog messiness that language represents. At this level, we mirrored the matrix rows to columns functionality to closely resemble a simulated neuronal-based configuration, with word synonym rows representing neuronal axons into which we fire simulated neuronal pulses. Each synonym node on each row neuron is connected to all other word nodes in the matrix. We therefore have simulated axonal and dendrite-based transfers across nodes, as pulses flow and die across local neuron fields in the whole matrix. We developed the matrices as closely as we can to simulate physiological brain functioning, and actually refer to the matrix group as language brains. As analog, we can see the matrix brains as images of real-world concepts, built from web language patterns that we can use to show machines how concepts stick together in our human world. At the output level, this matrix operational subsystem drives the multi-word to multi-word synonym word group building at client output stage. Our AI research arm is called NeuroVert, and I will just quickly show you a simple graphical representation of from the NeuroVert site of how our next level, the matrix or the level we're looking at, how the synonyms build at this level. Please keep in mind that although we showed here as a three-dimensional image, the actual pattern building is on a two-dimensional XY axis basis only. The third level of Gatfol operation setup is very much the same as the synonym matrix level. We deploy a massively scaled set of grammar matrices, again in the region of roughly 10,000 per cloud instance. Just to get back here, I just want to show you the image that we've spoken about, the three-dimensional representation. You can see here we've got, let's start, we've got we're running in the middle. I just wanted to see if we can get to the start. You can see there's a word with some patterns linked to it, the word cold. Okay, matrix built from grammar usage resembles relationships between concepts in our world. You can see the tree, wedgie, shade, and we get a pattern that represents cool. In our matrix, you can see cool, we label that. We can link that pattern to other patterns that look very much the same or that fits on top of it, and cold is very close, and that's how we do our semantic linking. Okay, just to get back with our cloud instances, all these instances have the same properties as the synonym matrices, except that neuronal connections and word nodes represent how words follow each other in a purely grammar progression. This is now our third level of Gatfol systems functioning. After many years of evaluating a multitude of theoretical models of processing, we eventually realized that synonym replacement is wildly more complicated than we could imagine. Just to give you a simple single word replacement example, And keep in mind that Gatfol functions on a much more complicated level of multi-word synonym equalization. The words hate, loathe, detest and abhor are listed as synonyms in most dictionaries, but on a grammar level we use them very, very differently. I hate pizza is fine, but we rarely say I loathe pizza or I abhor pizza. Whilst we can say I abhor the effect of prolonged war on children, I don't really say I detest the effect of prolonged war on children. We can therefore see that, as opposed to just semantic validation function, validation functions, we at Gatfol use grammar validation as well, and we feel this is crucially important to world-class synonym equalization quality. The grammar matrix functional level takes input from the RSS feed level, same as for the synonym matrix level, and in architecture is also built closely to a human physiological neuronal structure. The last and the fourth level of Gatfol operational functioning, and the one that took the longest to develop and test in the region of 4 years, is the Gatfol microsecond output delivery Hadoop style master and slave system. That's the one that you can see running here. Very much slowed down, and we just show one window. Again, it's massively scalable, up to 10,000 instances. This is an extremely advanced, very high throughput delivery function. As mentioned at the start, at current peak functioning output, we scale to over 70 megabyte of final text per second. All 10,000 master and slave agents function without any central master MapReduce-like function, which also means that no central redundancy check and fault tolerance functioning exists. All agents are interchangeable at microsecond timeframe level, from master to slave and vice versa to match system demands. 2 agent master levels exist, with master level 0 breaking chunks of input text in the region of up to 10 megabyte per chunk into delimited logical sentences, and master level 1 breaking those linguistically logical sentences into smaller multi-word processing packages for final processing by a slave level of agents. Ratio of master 0 to masters 1 is approximately 1 to 5, and of masters 1 to slaves approximately 1 to 100. Masters 0 functions to grab the feed from API client driven input. We found this master-slave division of 1 to 5 and 1 to 100 to be crucial in ensuring very fast processing. This enables Gatfol to be functional inside data streams in real time. And given the millions of algorithmic and thousands of database requests made for each word input package at really millisecond and microsecond levels, we feel is a major achievement, as far as we know not equaled by many systems worldwide. The system processes the same feed through multiple masters 0, with the first to finish to deliver output. This ensures stability in case groups of master 0 go down for some reason. Because no central agent command exists, all agents monitor self-functioning to determine master-slave switching. To ensure optimal balances between master 0, masters 1 and slaves, which is incredibly difficult to set operationally, by the way, we eventually settled on evolutionary survival of the fittest model, where each agent, in delivering its payload to another master or slave, also reports its current system strength in terms of successful operations completed in a set time frame. Stronger agents use this comparison test to switch weaker agents from masters to slaves. This functions in a kind of line, buck, grass, sort of environmental control manner, where all agents compete for survival in the available existence space. We found this worked very well as agent resource allocation model at very consistent and stable levels. The interchangeability of masters and slaves makes the system incredibly robust. We have keeled down from several thousand agents running across a prototype network system of around 27 desktop machines to just 3 agents in a few seconds, and with no compromise other than final output speed. Each agent, whether master 0, master 1 or slave, carries a full set of synonym and grammar matrix brains that automatically updates from Gatfol systems level 2 and 3 at set intervals. This incorporates the latest word concept patterns as resolved by Gatfol systems level 1 RSS feeders. This again ensures delivery system robustness with no central data repository that can fall over, but instead guarantees up to 10,000 duplicated data matrix feeds. To give an example of how fast Gatfol can process using the Hadoop basis, individual search input queries of up to 200 words are processed easily in microseconds. Now just imagine the massive search power that a 200-word search query can detail and capture. Our Dupe style final delivery system is very economical in terms of memory and storage space. Just 3 GB of RAM can run up to 15 master slave instances, with full matrix brain storage per each agent currently only 50 megabytes. We built in stringent CPU optimization technology to minimize CPU usage during operation. We wanted to be able to run full Gatfol functionality in as small as a single desktop to enable Gatfol use as a router-based single-chip hardware semantic filter, and also as standalone non-web connected Gatfol field instances, for instance in the surveillance industry where web connections are not always desired. In addition, we wanted massive scalability in terms of processing volume and speed, and hence a Hadoop-styled architecture. It's also worth noting that the whole 4-level Gatfol operational system is fully self-maintaining in terms of all processes, and this is right from web concept sourcing through to neuron health checks. Just as a matter of interest, we built in something like a simulated neuronal aging process where neuron endpoints slowly degenerate. This ensures that evolutionary healthy matrix neurons dominate and feed into the final operational systems. No human input at all is needed at any stage to maintain Gatfol output functionality. We have built in around 50 levels of fuzzy logic as well around many system variables to ensure continuous optimization of speed, volume, processing, and many other functions. To maximize speed and matrix storage, we eventually settled on a new word linkage model as opposed to an n-gram extended word linkage model. The latter quickly became unmanageable in permutation size when approaching n-grams of length 7 words or more. To make semantic processing jump from single 2-word chain links to multiple word chain links, we resourced many models and mathematical approaches over many years and eventually settled for a simplified Markov chain processing approach that we adapted in our proprietary multiple hierarchical levels of functioning as mentioned earlier. Okay, to end, this is just a very brief introduction to the Gatfol multi-word synonym equalization cloud-based operational setup. We've worked for 9 years on full development, and therefore obviously understandable that the full Gatfol operational strength and complexity is much more substantial than shown here. I'll try and cover more ground regarding Gatfol functioning in later videos. Please keep in mind that Gatfol functionality is delivered as an API-driven cloud-based service. And in a follow-up video, I'll also briefly run through the 27 or so industry application fields that Gatfol functionality can be commercially applied to. Thanks for watching. Thank you.